Hi gents, we're going to have a quick look here at some revision topics, and we're going to pick coordinate geometry today. No, I tell a lie, we're going to do complex numbers. That looks a bit like coordinate geometry and it's got a few elements in it. But here we go, we'll have a look here at question 1. This is from 2014, it's from a sample paper actually. It never came up on the Leaving Cert, it was just when they were changing the course. Okay, so how is it like coordinate geometry? What this thing tells us here is it tells us that W, point W right there, is equal to minus 1 plus root 3i. So what it's telling us here is that it's moved over a distance of 1. Okay, so this is minus 1 here, so that distance is 1. And it's moved up to root 3 on the y-axis. So that length there is root 3. Whereas that length there is 1. Okay, that's 1, that's root 3. Now, can you remember polar form? Well, certainly not. It's or cos theta plus I sine theta. Of course you do. Of course. What's or? Or is from W, okay, forgetting the lines that I've drawn in there, from W, or is that length there. It's the modulus. It's what is the distance from the point to the origin. And theta, very importantly, it is the angle starting from here. It's the angle that you have to make in order to go there, go to that particular thing. So let me just put back in what we have here. Okay, what do we know? We know that that length here is root 3. We know that that length there is 1. So we can get what or is by using, of course, Pythagoras' theorem. Nice and simple. Or squared is equal to root 3 squared plus 1 squared. Or is the hypotenuse in this case. That's or squared is equal to 3 plus 1. Or squared is 4. Or is 2. Root 4, 2. Okay, so right in polar form, well, or is 2. That bit's easy. Now, theta. You don't want to get theta straight away. You want to get what A is. And then we can work it out. Okay, so to get A, tan of A, maybe I'll just write it a little bit further over here. Tan of A is equal to the opposite over the adjacent. And the opposite is root 3. And the adjacent is 1. Okay, now that we know what or is, you could also have used sine or cos. But there you have it. So tan A is equal to that, so A is, the thing we want to know, A is tan inverse root 3 over 1. Well, that's just root 3. Okay, so you would type this thing into your calculator. If I had it on hand, it would be good. I'm sure it's 60 degrees. Can't be anything else in my mind. So tan inverse 60 close brackets. Well, that's not right. Sorry, I put in tan inverse 60 because I was going to hopefully what the answer, tan inverse of root 3, yeah, it's 60. So if that's 60, well, think about it. What does theta have to be? Well, the whole way over is 180. A is 60, so of course theta is 120. Okay, now if you want to be stylish, you can do it in radians. Remember, pi radians is 180 degrees. So you can get down to 60 degrees quite easily, divide by 3. And then to get back to 120, you would multiply both sides by 2. So 2/3 pi is fine. So it's up to you. You can call it cos 120 plus I sine 120. Or you can also say alternatively 2 cos 2 pi over 3 plus I sine 2 pi over 3. Okay, that's the bread and butter of it, is being able to change things into polar form. Please get it correct. Okay, it says solve this equation. So if this were asking you to get W squared, remember this was W, so W squared is just squaring it. Remember how you do it with De Moivre's theorem? You take the modulus and square it, and you take the angle and you multiply it by 2. Okay, that's what that would be, but that's not the question, unfortunately. But I bet a lot of people wrote that down in the Leaving Cert. It's asking you to find out what Z is. Solve the equation of Z squared equals something. So they want to get what is Z. Well, z squared is minus 1 plus root 3i, which happens to be the thing that we just got. And we know that the thing that we just got is that. We know that it's 2 cos 120 plus I sine 120. What we actually want to do is we want to go from z squared down to z. So the way that you do that is we're going to have to square root it or put it to the power of a half. So what we're going to do is we're going to take our 2 cos 120, but this is one of those cases where, you know what, let's not do it to the power of a half just yet. Let's just deal with this guy here. What we'll do is we'll call it the cos of 120 plus 360 n's, where n is a whole number. What does that mean? That means that what you can say is that in order to reach the point W, what you could say to someone is, oh yeah, I want you to turn 120 and go out 2. Okay, that would get you there. Well, you could tell them, I want you to turn 120 and then do a quick 360 and then go out 2. You'd still end up there. Or you could say, I want you to go 120 and then do 2 360s, do 720 and then go out 2. You would still end up there. So the point here is that it's also acceptable to put in 360n. It's called general form. You don't bother writing it in there because it's sort of, there's no need for it. In this case, when you go down, there is, because when you go down, if you have, we won't call it z for a second, if you have x squared is equal to 9, what number when multiplied by itself gives you 9? Everybody jumps in and says, oh yeah, 3. But it is, of course, plus or minus 3. There are 2 answers. So this is one of those that it's more tricky. Whenever you're going down the way, you have to write it in general polar form first. So we're going to go, to get z, you take z squared and you put it to the power of a half. Okay? You're square rooting it. So this other thing here, you're going to put it to the power of a half. So you're going to get 2 to the power of a half, which you can write as root 2. No problems there. And remember what we said, if you're putting it to a power, whatever the angle is, you multiply by. So we'll multiply by a half. So it's now the cos of 60 plus 180n plus I sine 60 plus 180n. Okay, so there we have it. We have z is root 2 multiplying the cos of 60 plus 180n plus I sine 60 plus 180n. And remember, because we're going from z squared to z, we expect to have 2 answers. So it's up to you to take 2 different but consecutive values of n is what I would suggest. So we'll choose 0, because this makes life easy. So we just get the cos of, well, that'll just be 60 plus I sine 60, n is 0. And the other answer that we get is root 2 multiplied by the cos of, here n is 1, so it's 60 plus 180, so that's 240 plus I sine 240. They asked, give your answer in rectangular form, that means a plus bi. Just do root 2 times cos 60, nothing tough here. Just go to your calculator, root 2 times the cos of 60, and that is root 2 over 2 plus root 2 sine 60. This will have i's in it. Let's see if I can manage to do that without changing much here. Sine 60, yeah. So that is plus root 6 over 2i. And now we'll do the same but for 240. 240. 240. I've got the sine part in, so that's going to be minus root 6 over 2i. Already had that bit. And we'll just get cos. I think it's going to be the same in that the sign is just going to change, yeah. Minus root 2 over 2. Okay, that's a good one for everybody to know. And there you have it. You got your 2 answers for it. Remember, when you take a number and you multiply by I, it rotates it 90 degrees. So here it says Z2 is Z1 times I. So Z1 was there, it got multiplied by I, and it went 90 degrees. Well, if we have a look, what has moved 90 degrees? The length is preserved, by the way, when you multiply by that. So that to me looks like a 90 degree one, and I don't think you would get that from any other one. So for me, and it's that length is the same as that whole length there, you know. So in this case, I'm going to say this was Z1, it got multiplied by I, and it went to Z2. I think that's a pretty reasonable one. What it says is Z3 is K times Z1. Okay, now if you think about it, when it's written as, you know, let's say it was, you know, 2 cos 30 plus I sine 30, what would that mean? That would mean you move 30 degrees and you go out 2. Well, if you multiply this by a number, okay, if you took Z1 and multiplied by a number, let's say 5, what would happen? If you took that and just multiplied by 5, this isn't de Moivre's theorem, it isn't raising it to a power. The thing, instead of having 2 cos 30 plus I sine 30, if you multiply by 5, you just have 10 cos 30 plus I sine 30. Okay, it wouldn't affect the angle there at all. So all that would happen is that it would still be please move out 30 or please move 30 degrees, but it would be move out 10 now instead of 2. So what happens is when you multiply by a number, the angle's preserved, but the length changes. And in this case, the only point there where it's the same angle, but the length has changed is this one. So this guy has to be Z3, and by default that is Z4. And it says write down the approximate value of K. So what did we multiply by in order to go from Z1 to Z2? Well, it looks to be half the length. So you multiply by 5. As I gave an example, you multiply by half. Okay, that is a nice little bit of revision on complex numbers for you. Just make sure that you go through it. And we've done lots of questions in the past, so good idea just to have a look back over your book and go from there. Okay, gents, any questions? Just drop me a message as always. Okay, thanks very much. Bye.